So, today we have Ignacio, and he's not even talking about bees.
Not talking about bees. But we're going to talk about honey, though, because I know how much everyone here loves honey.
I certainly do like
So
honey.
my title of my project is The Rise of Robot Bees and Tiny Drones That Turn into Artificial Pollinators. And the reason why I kind of selected that topic is because I'm not sure if you guys seen the Super Bowl this past, one was 2 weeks ago. Kind of the theme was kind of futuristic, using drone and artificial intelligence. So I tried to take a different spin on this project, so I chose this title. So like I said, why robots? So as you guys know, bee death has been on the rise. The numbers outpacing the colony's ability to regenerate. In 2016, the U.S. lost 44% of all honeybee colonies, and in fact, some species have almost reached mass extinction. Those are the rusty patch bumblebee and 7 species of the Hawaiian yellow-faced bee. So the article kind of quotes saying, a world without bees may seem far-fetched, but experts are looking for ways to help survive without them. And a researcher at Japan's National Institute of Advanced Industrial Science and Technology, they designed this little robot-sized drone that's capable of pollinating pretty much at this point all flowers. So the gel was discovered by, I'll try to pronounce his name, Erihiko Mayako. And actually this was a serendipitous mistake. He used to work with electrochemicals as his doctorate thesis, and every time those electrochemicals will fall short or they didn't do the purposes that they were intended to do, he would just tuck them away and put them in a drawer. And it wasn't until 2 years later where he actually thought about the collapse of honeybees and how there was something that must be in need of being able to pollinate. He went back to his shelf and picked up these ionic gels that he had to deal with about 2 years ago. And that's how he kind of discovered this gel that I'll talk about further. So like he says, conventional gels are mainly made out of water and they lose their stickiness over time. And for pollinating, it's that you have to rely on that stickiness factor to be able to move the pollen from one plant to the next. But he says this ionic gel is a substrate with long-lasting lift and stick again, it's very adhesive poly, which is, like he said, it's very important to be able to move the pollen from one source to the next. So the team went out to test the ionic gel, seeing if it was both biocompatible and eco-friendly against a lot of other pollinators. So they tested it against ants and flies, which are also pollinators, and found out that there is no harmful effects. And they also tested it on the cells of the mice. So with this attention, he settled for a little sized drone that we'll watch right now, and it's now commercially available for about $100. So this is how it works. It's encoded, has a patch of forced bristles with that ionic gel that we were talking about. And these tiny robots are good for being able to collect and transfer pollen from one plant to the next. And you can play that video and it shows us how this technology works.
Oh boy, here we go. Oh, I've been burned by TurboTax enough time.
That's it there. So currently, like you guys seen, it's still a work in progress. It's still mainly a prototype. It's not autonomous yet. The researcher, they're looking into building artificial intelligence and GPS so they can actually go out and detect which ones have been pollinated and which ones have not. I didn't put this in my presentation, but there was another researcher who mentioned that this technology might be more adequate in precision agriculture when you do more of the insect management, which kind of defeats the purpose because some insecticide might be harmful to bees. But he was talking about the approach instead of doing a full broadcast, a spray So the cons, there would be a lot of robots would be needed. There's about 20,000 species of bees, each with unique flying patterns. Like there was presentations before, I think it was Ramiro who gave one about how specific bees work best on different crops. And here's an example of how the bumblebee is a better pollinator for tomato, while the leaf cutter bee is a better pollinator for alfalfa. As Dr. Wenger mentioned, it's a rough landing on this one, so there's still the technology in the works. And kind of the most important thing is there'll be no honey, so that will be a downfall too, of course. Next slide. So the article ended with a comment from Quinn McFederick, who's an entomologist at UC Riverside, and he talks about that it makes more sense to protect our natural pollinators than to develop new technologies, and that's kind of where I stand too. I just thought it was interesting to throw something different out there, and he says, quote, "I would not like to live in a world where bees are replaced by plastic machines. Let's focus on protecting the biodiversity we still have left." And then the researcher is he's looking about the skepticism, and he says it's not really a replacement for bees, but rather a synchronism just in case if there's any human extinction or any bee extinction in the years to come. And then this is a quote. It's not part of the article. I just decided to pull it up because it kind of relates to what I'm talking about. And it says, "If the bees disappear off the surface of the globe, man will only have 4 years to live." I thought that was pretty interesting, and that kind of wraps up my presentation. I do have one more slide, if you can go to it. I was driving back home this weekend. Like I said, this has nothing to do with my presentation, but people ask, like, how do they transport bees? And I thought that was pretty cool. I mean, I was driving, maybe I shouldn't have done this, but I took a quick video. If Dr. Wenger would kind of...
It says I need,
maybe not, you might not be able to play it, but it's just that image of that picture there. I was surprised that they weren't transporting them by night. Kind of my question to Dr. Wenger is if there was any bees in there, or if this might be just vacant.
I mean, there may very well be bees in there. I would imagine they're not just shipping around empty hive boxes at this time of year.
Wouldn't it be at night as well? Because they're in day to find out.
I think what they could do, and I'm not exactly sure. This would be a good question for Mike when he comes in, or we might be having someone come in, Bob Nyberg or Bob might come in today. We'll see. But they might just tap shut the entrances. Yeah. So what you can do with bees, right, is there's only one entrance to the hive. So if you have them strapped down, you can just put like a little bar over the entrance, so the bees can't get in and out of the hive. So you can do that and transport them during day, during night, whenever you need to. So it's very possible that this is a great big old truck full of bees. But yeah, so I sent a permission. Oh, nope. I'm not sure if they would overheat inside. I imagine they would if you had them in there long term. But that's a good question. Hopefully, so I got a call last night from this local beekeeper, Bob, and he said he had heard I was teaching the class. He wanted to know when and where it was. I told him, he said, "Oh, I'll see you tomorrow." Okay. So maybe he's coming. Maybe he's not. I'm kind of hoping he is, because the last section of the presentation today, I was having a little trouble finding info, and I think he'd be actually a pretty good source to figure it out. Anyway, just a reminder, we talked about this a few weeks ago. Yeah, no, not Bebo. Just a reminder that next Tuesday we're having a guest speaker. This was originally the time for the exam, was Tuesday the 19th. But I wanted to bring in this guy, Billy Sink. He's from a group called Project A to Z, which does bee conservation. And he's done a lot of research with them on basically building foraging landscapes for bees and integrating forage with crops. So like doing things like planting, flowering border rows in orchards and vineyards and business like that. And so he's going to come in and talk to us about some of his work in that. And he was only available on the 19th. So we're pushing the test back one day. It'll be on Thursday, the 21st, so 1 week from today. And there's not a study guide posted as of right now, but there will be a study guide by the end of today. And it's going to be a pretty typical study guide in my style. There will be keywords and there will be key concepts.
Do you know what the test might look like?
Well, it'll be written on paper and
Paper test.
paper test. Yeah, you know what? Scantrons are so nice. Bring a Scantron. One of those things. You can tell I've really thought this test out. Yeah. I've pushed out enough of these things. All right. But anyway, yeah, the test is probably going to look like most of my tests. It's going to be a fair chunk of multiple choice. There will probably be some short answers and then maybe one or two longer essays. But I feel like most of this material is pretty well suited to multiple choice and the like, so we'll probably see a fair bit of that. Swarming. So we were talking about how queens get replaced, right? And last time we focused in on supersedure. Today we are touching on swarming. So swarming is different from supersedure in that swarming is triggered basically when the hive is too large for a single healthy queen to support it, right? So in a supersedure, the queen is usually becoming weak, whereas in a swarm, it's just that the hive is too big. And functionally, it looks very similar to a supersedure. The queen, right, is getting that constant feedback of queen substance from her attendants. She starts getting lower and lower doses, and eventually that will trigger the behavior where she will go and lay her eggs in a queen cup. Now, oh, hey Bob. So, where this is going to differ is, here. There's a spot up here, and you can also give me one of the desk chairs. Actually, I'm glad you're here because I had a question. We'll get to it towards when we talk about forage a bit more. Okay. All right. So she'll lay them in queen cups. Typically, the queen cups in a swarming situation are near the bottom of the brood frames. And then where this differs from a supersedure, right, is that instead of the virgin queens emerging and the workers balling them, when the virgin queens are about to emerge, usually 1 to 2 days beforehand, the queen will take 40 to 80% of the hive and she'll vamoose, right? They will leave the hive and they will search for a new nesting location. Now, we had a question last week, or last Tuesday, about what is it that causes swarming? So if queens are basically deciding to produce new queens purely by how much queen substance they're getting in their feedback loop, then how do they know that they're supposed to swarm versus how do they know when they're being superseded? And I looked into this, and it seems like it's not particularly well known what triggers a swarming event versus a supersedure. But that being said, there are a number of factors that are associated with swarming, one of which is seasonality. Generally, swarming takes place in about a 6-week period. And admittedly, this is a book that's written by a bunch of guys in Delaware, so it's a little more oriented towards the East Coast than it is towards Californian beekeeping. But typically on the East Coast, swarming is mostly in mid-spring to late spring, maybe even early summer. It tends to be associated with the spring period by photo period as well, so the bees seem to be aware of day length, and they can use that to determine if they're swarming or not. Genetics, just that some bees are more prone to swarming than others are. Sort of like we talked about, the Africanized bees are very frequently swarming as opposed to European varieties. Age of queen, young queens are more likely to swarm than old queens are. The pheromone concentration, and also the bees seem to be watching out for physical crowding as well. So, this is perhaps unsurprising, but like I mentioned before with aphids and entomology, right? Aphids are kind of aware of when a plant gets crowded because they're bumping into each other a lot, and that can trigger gene regulation changes that cause them to switch to a winged form. Similarly, honeybees seem to be aware of when the hive is getting extra crowded, and that can trigger swarming as opposed to supersedure. So if we're looking at a swarming timeline, the queen will lay the eggs, and it'll kind of proceed along similar to a supersedure. But about 10 days before the swarm actually happens, we're going to see some slight changes in behavior. The first thing is that the queen is going to stop eating as much. She's going to be fed less by her attendants. She's going to lose a lot of weight. About a third of her body weight will be dropped, and most of that's going to be egg weight. So she's going to be producing less eggs in her ovarials. She's going to lay less eggs during this period, generally just be less productive.
So does she get fed less because the workers know that the swarming is going to happen, or does she just request or beg for less food?
That's a good question. I do not know. Do you know?
What was it exactly?
He was asking if, basically, is the queen eating less because she's requesting less food, or are the workers refusing her food when she asks for it?
Well, if she knows she's gone, she wants to lose weight so she can fly. They've seen African queens dump their eggs.
Okay, so that would suggest it's more of the queen's own choice, that she's probably requesting less. And
she's in charge.
Well, there we go. But so, similarly, there is some research that suggests that the workers are a little extra rough with the queen during this period, sort of shake her around a bit more. And during this period, we see sort of the opposite in workers, that the workers are going to start gorging on honey. They're going to start building up fat reserves. They're going to start keeping their honey stomach fuller because they're getting ready to travel outside the hive and be away from their food source long term. So generally, the workers fatten up, the queen skinnies out, and then we see swarm emergence. So again, as I mentioned, this is typically in the springtime. In the East Coast, it's a little narrower. If you go down to like Southern California where they have eucalyptus blooming in the winter time, you'll see swarms basically all the time because the bees have these winter food sources and they'll build up their populations. But in most cases, it's a relatively narrow window. Typically, bees will emerge in a swarm around midday when flight conditions are ideal. So you've got nice warm weather. And this typically takes place just 1 to 2 days before the virgin queen emerges. So it's kind of like the mated queen vamooses just before she comes out. So there's no real overlap between the two, but also, excuse me. But also so there's as small of a break in the brood production as possible. Now, there are some situations where the old queen and the new queen will overlap. That's typically if there's poor weather for the couple of days before the swarm emerges. So like if it's raining, the bees won't swarm during a rain event usually. So they'll stay inside the hive, and you might have a couple of virgin queens roaming around in the same hive as the mated queen. So as far as leaving the hive is concerned, what's going to happen is the bees will signal leaving the hive with another dance. It's called the whirring or the breaking dance. But basically, when it seems like it's time to leave, some of the workers are going to start doing that zigzag pattern that we see up the middle of the waggle dance. And they'll do these long lines of buzzing. And basically, other workers will see it and they'll pick it up. They'll sort of start herding the bees towards the opening at the base of the hive. And by what it sounds like the queen kind of gets caught up in this wave of bees. They all kind of just bubble out. And typically a swarm can exit a hive within 10 to 15 minutes. And we're talking about, tens of thousands of bees. So it's a relatively quick exit out. So here we have just a picture of some bees coming out of the swarm, or out of the hive. And when they leave, what they will do, a long video, we're not going to watch the whole thing, is they'll kind of fly up in a big circling pattern in the air, waiting for the queen or for the rest of the swarm to come up. So as you can see, yeah, they're just really boiling out of there. So as far as researchers know, there we go. There's no apparent determining factor for who stays and who goes. Anywhere between typically 40 to 60% of the workers go with the queen in that initial swarm. It can be higher, it can be lower. There have been some cases where like 80% leave, some cases closer to the 20%. But in general, it seems that it's random assignment. There have been studies where they have captured swarms, marked the individuals who were swarming, and then put them back in the exact same hive they just came out of, so they will re-swarm and leave again. And they found that individuals in the first swarm, many of them stay behind in the hive the second time around. So it seems that, it's probably just they start the whirring dance, and maybe you're standing in the right place at the right time, you get caught up, and you end up going out the hive with the queen. Maybe the next time around you're standing, up in the super, and you miss the swarm. But in general, it seems that the bees that do go into the swarm, it's biased towards young workers, so workers that emerged 4 to 23 days ago, which again, I think is in line with the idea that these bees are getting randomly swept out of the brood box because your younger bees are going to be more concentrated around the queen. They're going to be mostly the nurse bees and things like that, so they might get swept away more easily. And the swarms also tend to have a certain number of drones, not a particularly huge amount, but studies looking at swarm composition have found usually about 50 drones on average in a swarm. So, the swarm comes out, right? It buzzes around in that big circle, and what will happen usually is the queen will fly, and she will look for a temporary resting place. Some people refer to this as a bivouac. But she wants to find some sort of place to rest. She sits down, she releases her queen substance and tergite pheromones, a variety of pheromones. Those are serve as attractants to the rest of the swarm. They come over to where she is, and they will basically surround her. Create a little swarm, a little resting cluster, what we usually think of when we think of swarms. And typically, swarms will settle on some sort of elevated place. They like things that are about 9 to 10 feet off the ground, usually. Small tree limbs, fence posts, mailboxes. There's a surprising number of pictures of them resting on people's bikes. I think mostly in European settings. And oftentimes, if you've got bees in the same apiary for many years in a row, bees are going to utilize the same temporary resting sites year after year after year. And a big reason that appears to be the case is that the queen pheromones really stick to the materials where she rests. And so queen pheromone is detectable year after year after year. So the swarms will kind of just naturally settle in places where they can find that pheromone. There was some research where a bee researcher, I'm trying to remember how this worked. Basically, they were creating swarms out on the water, so he had this little sailboat, and he put a queen and her swarm on the mast of this boat. And he found for 6 years he was constantly getting bees, on his sailboat, because they kept coming back over and over again to that queen site. So once they're in that temporary resting area, they can stay there for a few hours. They might stay there for a few days. But generally, they're staying there just long enough to find, that worked out well, a new nest, right? They're basically just there hanging out, waiting to find a new nesting site. So while they're hanging off on the tree, the swarm will send out a handful of scouts who are going to search the surrounding area. And they're going to look for an ideal nesting site. And it's going to be a nesting site that follows those basic rules we talked about previously when we talked about natural hives, right? They're going to be in closed spaces. Bees prefer things that are a little higher up off the ground with high entrances. They like things that have been previously used by bees, so they look for things that smell like bees. Basically all those nice things. So workers go out, scouts go out, they look around, and if they find a suitable nesting site, they come back to the swarm and they start doing the dance, the waggle dance, on the outside of the swarm. Basically saying, I found a site, I found a site, I found a site. And it seems that these scouts have a basic innate measuring stick by which they determine what is a good site versus what is a bad site. And they will calibrate the length and vigor of their dance based on how good of a site it is. So, like 5-star bee mansions are going to get like really long, really vigorous dances. Shanty villages are going to get relatively short, crummy dances. So, if the dances are really strong, indicating a really good nest site, the dances will recruit other scouts to basically go and view the site and to do the dance for that site as well. And it seems to be the case that functionally, once sort of a minimum threshold is met for total scouts, that will indicate to the swarm that they have found a suitable nesting site, and the swarm will start to travel to the new site. Typically, a number of scouts will stay at the site, and they'll fan the Nasonov glands, which, as you may recall, the Nasonov glands are the pheromones in the tip of the abdomen that basically can signal a really good food source or a water source or a nesting site, and the swarm will home in on that. So there's been some really interesting research into the question of, well, what happens, wrong button.
Press that arrow.
Thank you. That's the one. So there's been some really interesting research into the question of, well, what happens if the bees can't decide on a site? So what if, A, there's no good sites, or B, what if there are two different sites that are pretty comparable? And what they find is that if all the housing locations are functionally the same, you can have this sort of bee stalemate, where the worker bees, the scouts basically can't figure out which one is better. They can't recruit that threshold to go and choose an actual site. And in some cases, this can be bad enough that the swarm will be sitting in place so long that they'll start actually building comb onto the temporary site. The bees will get hungry, they'll get more agitated, they'll generally be less friendly than swarms typically are, and they can get aggressive with people who bother them. So, what this one research found, this is kind of fun, they took a beehive that was swarming and they transported it to a little island off the coast of Maine. This is a little tiny island, and they put out 2 Langstroth hives, or 2 nuke boxes, or something like that. Basically 2 really good bee habitats, and they put them up in the air where bees like them, and they set them out equal distance from the swarming site, and they basically would mark the scouts that went to the various hive boxes, and watched what they did when they got back to the swarm. So these marked bees would go back to the swarm and they'd do their dance, and they were having trouble recruiting bees, and what they found was that the scouts that were advocating for one box would go and start basically pestering the bees that were advocating for the other box. So they'd go up to their waggle dance and they'd start butting heads with them, like getting in front of them and pushing them back. They'd buzz their wings really loudly in the middle of the dance so the other bees couldn't hear them, and just generally try and disrupt it as much as possible. And what they found was that basically the group of scouts that could overpower the other group even just a little bit to get that initial edge, they would eventually recruit more scouts to their cause than the others would, and they would choose that site over the other. So it seems like the scouts will actively interfere with each other to advocate for their site if they think it's good enough. All right. So as far as a new hive is concerned, typically when bees settle into a new hive, it's usually pretty close to the old one, usually just 300 to 400 meters away. That's why we actually get a fair amount of swarm settling here on campus from the farm, and it tends to happen right here on the northern edge of campus, sort of around East Engineering. Speak of which, I guess 2 things. I got word from the dean's office that they're putting the hurry up on the equipment, so hopefully we'll have that within the next 2 weeks. But they said they wrote up a PO and sent it out, so it should be ordered. And I also got the word from campus, the campus ground crew, that we are their #1 stop for new swarms. So, so hopefully we'll have a chance to go out and collect some swarms again later. So that'll be fun. All right. Yeah, and if the hives manage to establish, generally there's about a 25% survival rate in wild hives. But if they do establish, they tend, if they survive the first winter, they tend to survive for 5+ years after that. So they do pretty well. All right, so that's swarming. Any questions about swarming before I move on to other business?
I don't know if you brought it up, optimal height for setting up like swarm traps.
Yeah, so bees, as best I can tell from the literature, bees kind of like hives that are kind of in that, like 6 to 10 foot range. So they like things that are a little higher off the ground. And they like things that have a high entrance relative to the ground. That's been one of the criticisms of the Langstroth hive, is that they put the entrance pretty low unless you have it raised up. But yeah, so that brings up a good point. I didn't mention that. But what some people will do and some keepers will do is they'll set up swarm traps. So like I mentioned before, right, if you have an apiary, a place where you keep all your boxes, you can kind of expect swarms at a certain time of year and on a semi-regular basis. But you're not always going to be there to see the swarms. So what some keepers do, right, is they'll set up basically a trap box. They create an ideal hiving situation for the bees, and they put it somewhere, within a couple 100 meters of their apiary. And so the idea is when the swarms are sending scouts out, the best possible location is going to be that swarm box. And so, when you come back to your apiary, if you see there's a bunch of bees in your swarm box, you can just collect that and rehome it into your hive. And if you use the same swarm box over and over again, it's going to smell like bees. And bees like that. So they'll keep using it over and over again. And some of these swarm boxes are like nice wooden structures. I've seen designs where basically people get a piece of plywood and they screw one of those compostable flower pots on there. They just sort of drill a little hole in the top. Apparently bees will rehome in that too. So, doesn't need to be anything fancy. Bees like dark cavities with a hole in it. So, absconding. I just wanted to point out absconding as an alternative to swarming. So, absconding is a process where basically most of the adult bees abandon the nest site. It can resemble a swarming event, but it happens without a new queen being formed. So basically the bees pack up their bags, they leave, and they go look for a new nest site without provisioning a young queen to maintain their current location. And typically, this is going to happen when there's something wrong with the hive. This is going to happen if there's, say, no brood production, if the hive population is really small, and also just if it's a really poor nesting site. If it's a poor location, there's not very much forage. If the bees are constantly being bugged by smoke or dripping water or chemicals, they're basically going to look at the site and say, this is not the kind of place we want to live. We can probably find a better nest somewhere else, and they'll pack up and they'll fly off somewhere else. Now, absconding is not super common in European bee varieties, but as you may remember, Africanized bees tend to swarm a lot. They also tend to abscond a lot. So they're pretty quick to abandon a site and go find a new one. All right. And then lastly, as far as queen replacements are concerned, there's emergency queen replacement. And functionally, this is this is just a situation where if the queen dies, she can't lay eggs, or basically she's injured in such a way that she's not putting out very much queen substance. This is how bees go about replacing her. So in this situation, what the workers do is, so they don't have a queen, right? So a queen can't lay an egg in a queen cup. So how do they go about this? What they do is they basically take existing brood cells that have a young egg or a young larva, usually 2 to 4 days old, and they will modify the cell that that larva is in to create a queen cup. So they'll usually remove the bottom sort of lip of the beeswax cell. They'll build sort of this long encapsulating structure, and they will start feeding that larva royal jelly at really high amounts to create a queen. That's basically it. The way you can tell the difference between, say, a traditional swarm and a supersedure, or sorry, the way you can tell a swarm or supersedure queen from, say, an emergency queen is that in emergency queens, all of these are going to be in the worker cells, where they're rearing the brood, instead of being at the bottom of the comb, where we expect that to be in the swarms or supersedures. But what happens if there aren't any young eggs or larvae to work with? Let's say that the queen dying happens at an inopportune time, or maybe her death was a little drawn out so that there aren't any more young larvae that can be manipulated. If that's the case, well, then the workers are really just stuck. The workers can't lay fertilized eggs, and this is where a keeper needs to intervene. The keeper's going to need to provide a alternative queen, a new queen, for that hive, and basically allow the bees to acclimate themselves. Or the keeper will need to provide some sort of brood comb with young eggs or young larvae in it that the workers can take advantage of. Now, there are some signs you can look for to see if your colony is queenless. So let's say your queen dies, but you haven't made it out to to check the hives for a while. One thing you can look for is the presence of what we call laying workers, where basically without the queen, there's no queen substance, there's no pterodite pheromones, there's no brood, and brood pheromones. And so the workers' ovaries are going to start developing again. All of a sudden, the workers are producing a handful of eggs, and they're going to start laying eggs in themselves. But what we find is that workers aren't really as good at laying eggs as queens are. Queens kind of have just the right abdomen length to deposit eggs right at the bottom of the cell, right in the middle. Workers don't really have that, so oftentimes they lay eggs up on the sides of the cells. And workers also will just lay many eggs in a single cell. So if you pull out your brood frame and you see something like this, right? You've just got a ton of eggs in your cells. They're all scattered around randomly. You'll have eggs stuck to the sides of the cell as well as in the bottom. That's a good sign that your queen is gone. You've got a bunch of laying workers in there taking care of the hive. And again, because these are unfertilized eggs, they're all going to be drones. So if you open up a hive and there's just a ton of drones, that's a sign that they're in trouble. And also, the drones that are produced by these workers will sometimes look kind of funny because they'll rear them in worker cells instead of drone cells. So the drones don't have very much room to expand in them. So you'll get these drones that are basically the size of workers, but have the big drone eyes and the other drone features. All right. Cool. So that's it as far as how queens get replaced, sort of a hive life cycle and the like. We're going to jump into foraging. Any questions about that before we jump over? Anything you'd like to add?
About swarming, you mean?
Yeah.
Well, the Africans are different. They'll go year-round, like you said, and way smaller.
Much smaller swarms?
Yeah,
Okay.
any time of year.
Oh.
Europeans will go mostly up till the equinox.
Okay, and that's pretty typical around here as well, that they'll go up to the equinox and that's about it.
Yeah.
Okay. So, something else I didn't mention is something I read in the book that I wasn't familiar with, was the idea that sometimes you'll have something called an after swarm, where the original queen will leave with the swarm, and then a second swarm will follow that has a number of virgin queens inside of it. Then they go off and sort of establish their own hive as well. So you might have multiple swarming events all in one go. All right. So foraging and bee biology, or bee botany. So basically what we're going to focus on here is basic foraging behavior. This is going to wrap up our bee biology section of the class. So we're going to go through this, Billy sync on Tuesday, test on Thursday, and then following that, we're going to jump into some basic beekeeping. So we're going to jump into introduction to keeping bees. We're going to go to Date Ant and see the showroom and various other things to just sort of get familiar with the actual practical aspect of keeping bees. So foragers. For the most part, when we're talking about bee foraging, we're talking about travel to and from flowers, right? Flowers are going to be the source of pollen, their protein, nectar, their sugar source, and many flowering plants also produce the resin that they use to make propolis. So flowers are going to be the main stop, although we do see travel to water sources as well. Generally, what we find is that foragers are capable of recognizing flowers by their color, their shape, and their scent. We've already talked about some of the colors that bees really like, that they really like things in the ultraviolet range and the sort of the purples and blues, though they're pretty good at recognizing yellows and oranges as well. Reds, not so much. But as far as forms are concerned, they like broken forms. So broken round forms, they like to see distinct petals. But all considering, it seems that scent really is the most important. Bees really focus in on scent. It appears to be the case that they use the shape of the flowers to recognize something is a flower, and then they kind of zoom right up to it, and they use scent to determine if it's the specific flower that they're looking for or not. Generally, what we find is that foraging is a learned behavior. So bees, when they first become foragers, are going to leave the hive. They're going to do a lot of scouting, a lot of practice flights to sort of figure out the landscape. And generally, what they will do is when they find their first flower, either they're going to be scouting or they get recruited there. They're going to learn how to pollinate that flower, or they're going to learn how to get nectar from that flower, or whatever. And they're going to tend to stick with that flower for as long as possible, that specific species, because they have to learn how to do it efficiently. And the older the bees get, the more they utilize that resource, the better and better and better they're going to get at doing so. We also tend to find that foragers tend to segregate by what they're collecting. So when a bee flies to a flower, it's usually not just like, collecting nectar and incidentally collecting pollen along its way. Generally, what you see is there are dedicated nectar collectors, there are dedicated pollen collectors, and there are dedicated propolis or water collectors. So usually, the majority of bees, about 58%, are going to be out there looking for nectar, while a smaller number, 25% or so, are going to be out there exclusively collecting pollen. That's their preference. The rest of that is going to be some mixture of water bees, propolis bees, or bees that are collecting both nectar and pollen at the same time. And you can sort of see this when you're out looking at bees, that nectar-focused bees are generally not going to have a whole lot of pollen on them. They're going to look a little cleaner, whereas pollen bees are going to have those nice full pollen baskets hanging off of their legs. And I say this 58-25 number, this is all variable, right? If you've got a ton of brood and you need more pollen, you're going to see this pollen number go up. If your brood numbers are low and you've got a big nectar flow going on somewhere, you're going to see more nectar production. It's all variable. So as far as foraging is concerned, what we find is there are 4 major ways that bee researchers classify foraging, sort of 4 major behaviors they see. The first of which is what they would call crop-attached bees with a good source. So basically the idea here is that this is a group of foraging bees who have a really good food source in a very specific location, and they're just traveling back and forth from the hive to that food source over and over and over again. They're going to continue utilizing that source for as long as it's still a good source. And so they're very focused on just collecting, collecting, collecting. On the flip side, what happens if you've got a very clear floral resource, but it's not particularly good? They would call that crop-attached bees with a poor source. These are bees that, again, are traveling back and forth to a collected site, or a normal site, but it's either failing, so it's past its prime, or maybe it's not a particularly attractive thing. Maybe it's the best flowers they can find that day, but they're not particularly great for the bees. These bees will travel back and forth, but there's also going to be a certain amount of wandering. They're going to go around searching for alternative sites to gather their nectar and pollen at. Beyond that, there are what we would consider conventional scout bees, or bees that are just actively out there looking for new forage. And then there are what are called unemployed bees. Unemployed bees are those that are not actively searching for food, they're not actively collecting food for at least part of the day. Or they only go out and feed on a very specific flowering source during a certain amount of time. So this is kind of the forager reserve that's sticking around the hive waiting for some great resource to come along. Consequently, when scouts come back and do their dance, oftentimes they are gathering their foragers from this unemployed population. So unemployment is an issue even in the bee world.
They sound like lazy.
Are the drones included in that unemployed, or is this just the female worker drones?
It's just going to be the female workers. Drones don't forage, and drones don't even have the equipment to go foraging, really. They don't have as many hairs and the like, and they've got kind of reduced mouth parts, so I don't think they're really capable. Drones are really the lazy, they're the true lazy bums. Like, we call unemployed bees unemployed. They'll go out and forage as soon as they get the signal. Drones just hang out and eat pollen, and, Admittedly, I did cut out a section because I want to finish this all today. There was a really interesting section in the Swarming chapter on drone behavior and how drones have what they, I lost the word, but they have basically these drone runs, areas where drones will congregate to mate with queens. There's all sorts of interesting stuff. Basically, right, like the drones mate with the queens in there, they kind of latch onto them, then they flip over on their backs, and their oedicus pops out and explodes.
I think they're called DCAs, drone congregation areas.
Yes, DCAs, thank you. Yeah, and so they basically inseminate the female explosively, so when they twist off, the oedicus pops, which you remember is the insect penis, functionally. And it just like blasts a bunch of sperm up into the female, and the drone basically dies on the ground because he just tore off a pretty substantial chunk of his abdomen. But yeah, it's really sort of interesting stuff. I'd recommend reading the chapter because it sounds like these drones basically have preferred congregation areas where they mate, and you can sort of figure out where those are. You can create them artificially if you're trying to create a mating area near your apiary. I just did not include it because it was a crunch for time, which I'm now wasting talking about it in class. Cool. So, scout bees. Let's talk about scouts. So, scout bees are essential to finding forage because scout bees are the ones who are going to find foraging sites, right? If you're a worker, if you're an unemployed worker, or any worker, the only way you're ever going to find a forage site is either because you scouted it yourself, or because a scout bee came to the hive and did a waggle dance and told you where it was. So scouting is kind of the real backbone of foraging behavior. Typically, scouts are going to represent anywhere between 5 and 35% of foragers, depending on if you have a really good food source or not. But what we do see is that even when you have a really great food source, if you plop down bees in the middle of like their favorite food source, there's still going to be a certain number of scouts going around. The bees are always looking for something better. But it might just be a very low amount, like 5% of total foragers. Scouts typically fly out in the early morning when resources are most marginal. They're looking for those flowers, and when they locate them, excuse me, they come back and alert the foragers. And basically from there, it's like we talked about last on Tuesday with the dance, right? That the forager comes back, they do the dance. The unemployed foragers that they round up basically use distance and direction to get to the location. They use scent to find the specific flower that they're talking about. And then when they get to that flower, they spend a fair amount of time, the first time visiting it, learning how to use that flower. So they learn the basic shape and color. They learn where the nectaries are. If they're going for pollen, they learn how to collect that pollen off the flower. And when they leave the site, they spend a lot of time memorizing the site. So usually about 10 to 11 seconds after leaving the flower, they'll buzz around in circles in the area. And what they're doing is they're fixing the major landscapes and landscape markers in their memory. So they're learning, what does this site look like? What do these flowers look like? Then they return to the hive. That way, when they come back, they can get there much more quickly, much more efficiently, and they can get to those flowers right away. They don't have to spend a whole bunch of time smelling things. So, bees can forage a substantial distance. There's research that shows that bees will forage as far away as 5 miles from the hive, but that's sort of the extreme. In general, it is the preference of the bees to stay close to the hive, as close as possible. Because bees need to learn how to navigate the outside world, so the farther away they fly, the more of a chance there is that they will get lost and they will never come back to the hive. So the closer they can stay, the more landmarks they have, the happier they're going to be. And what we also find is not only do they just stay close to the hive, but they oftentimes will just visit a very limited section of any given field that they're nearby. There's been research that has shown that if you put bees in, say, a field with trees, that some hives will use as few as 1 or 2 bushes or trees in a single day. They'll really focus on a single floral resource at one given time. So if there are really obvious landmarks and there's lots and lots of nectar available, we're going to see this area they use become extremely narrow because they can navigate there very easily and they don't have to use a bunch of resources to get the amount of food. That being said, on the flip side, that got ahead of myself. If the nectar is less available, if the food source is not ideal, if there are less landmarks, the bees will scatter a little bit more and search more widely for food. What we tend to find is that as the workers age, they're going to learn more and more of the landscape, and they're going to go further afield when they go and forage. Typically, young foragers that are new to the game, they're going to stay within 200 to 500 yards of the hive. They don't like to go very far. But those old foragers who have been doing this for a long time, they'll go upwards of 4 or 5 miles to go find really ideal food sources. And we also know that foragers do have food preferences. If foragers, basically the point here is foragers like to stay close to the hive, but if there is basically if they know there's a super desirable floral resource that's further away, they will bypass less desirable flowers close to the hive to get to that better one.
Will bees ever follow other foraging bees, or do they have to be told through a dance, or are they just scouting? Like if there's foraging bees that see a dance, so they're flying out to the site, will other bees see them
Yes.
and just like jump on their trail?
Yeah, they don't have to be unemployed. Oh, I see. So you're saying, like, let's say you're foraging and you see a bunch of foragers, but they're flying a different direction from you. Would
Yeah.
they stop foraging on their flowers and jump over and go to the new site?
Yeah.
I don't believe that happens. I haven't heard of that. Have you heard anything? I think they have to observe the dance.
No.
There has been some research.
Follow the smell.
Oh yeah, or follow the smell if they're doing sort of a scouting behavior. But my understanding, there's been some research that's shown that foragers are also naturally conservative. They have a preference for their particular flowers and their particular location that they've learned, and they will not abandon that site even if there are scouts that are advertising a resource that's supposedly 3 times better than the one they're working on. They will stick with their site. You need to have a source that's like supposedly in the range of like 5 times more productive than the one they're in right now to encourage foragers to jump off to a new floral resource. So as far as nectar is concerned, nectar functionally, right, is just a sugar solution that is secreted by plants as a reward for pollinators. As best we can tell, nectar does not serve any other purpose. It's just there to encourage pollinators. Consequently, it is typically secreted from the flower, though we do see some extrafloral nectaries, which may be on other parts of the plant beyond the flower. But generally what we find is that nectaries are concentrated at the bottom of the flower in such a way that if a bee comes along, right, and wants to get it, the bee's going to have to crawl deep down into the flower and bump up against those anthers and stamens and really force the pollination to happen. Because bees will cheat. Bees will find ways to get nectar without touching the pollen if they can. So lots of flowers have to be a little tricky to get bees to actually pollinate them. But anyway, as far as composition is concerned, it's mostly sugar solution. There are a lot of sugars that can show up, but the main players are sucrose, glucose, and fructose. Generally what we find is that if given a choice, bees really like high sucrose content. That seems to be their favorite of the nectars. So flowers with high sucrose are what they'll go for first. Glucose is a second choice, and fructose is definitely sort of a distant third. There's actually maltose kind of falls in here in the true third category, but it's a much less common sugar, so I didn't bring it up. Well, there, I just brought it up. I didn't put it on the slides. Typically, nectars are in the 20 to 50% sugar range, weight by volume, though you can see it as low as 5, as high as 80. And as far as scent is concerned, oftentimes nectar will carry its own scent that's attractive to bees, or its own flavor. And that could be from acids, salts, oils, any number of organic compounds that are put into the nectar in really trace amounts by the flower itself. All right, so something that's good to keep in mind, sometimes when we talk about flowers and nectar, it's kind of this assumption that, oh, there are flowers, they have nectar in them, this is a great thing for bees. But what we find is that the availability of nectar varies tremendously across plants, across times of day, across times of year. There's really a lot of variability. I just wanted to highlight a couple factors that can make a plant more or less available to bees. Field conditions are very important. In general, if you have a crop, the healthier your crop is, the better it's going to be for bees, because it'll produce more nectar. So what they found when researching crops is that the plants that are growing in the best soil, with the best nutrition, the best moisture content, the best, basically everything, the best weather conditions, are going to be the ones that produce the most nectar and the best quality nectar for the bees. So generally, good crop, good nectar. Season also seems to matter. It tends to be the case that plants that flower in the spring have higher sugar content. It's believed that the reason for this is that most plants flower in the spring, so it's really high competition, right? You only have so many bees, all the plants need to get pollinated. So if you're the plant with the very highest sugar content, you're most likely going to get visited by bees. So you've got all these plants basically in an arms race with each other to produce high sugar content for bees. When you look at summer and fall flowers, they tend to produce much less sugar, but there's also a tendency for these flowers to have much higher nectar reserves. So they tend to produce more nectar, sort of to compensate for that. Time of day. Flowers oftentimes secrete nectar at varying times of day. Sometimes with bees, what you will see is they will have sort of flower schedules where they have certain flowers they visit in the morning because that's when the nectar's flowing. Then they'll move to the next species mid-morning, the next species midday. They'll kind of shift around, moving from flower to flower to flower, finding those nectar resources. And then finally, prior visitation. Generally what we find is that the best quality nectar is going to be the nectar that's there when the flower first opens. Once a bee visits it, the quality of the nectar is going to decrease. It's possible that a bee or a hummingbird or a fly or whatever pollinates it is going to completely remove the nectar, so it has to regenerate. There's also some really interesting research that bees carry yeast and bacteria in their gut and on their mouth parts. And when they feed on the nectar in a flower, that yeast and bacteria will start living in the nectar in the flower. And it will start consuming the sugar that's in there. It will change the sugar composition, the acidity of the nectar. It will also change the temperature of the nectar. There's been research where they've shown that flowers that have been pollinated are warmer than other flowers because they're actively fermenting. And so that'll change how much the bees want to visit those flowers as well. So we already talked about bees and color, but so just as a reminder, well, this is a little different. So flowers oftentimes will give bees hints that they have nectaries and will give bees hints to where the nectaries are located. Oftentimes they will use color. So many flowers have sort of bullseye patterns in the UV range. So this is the same flower with a conventional camera versus a UV camera. And as you can see, in the ultraviolet range that the bees use, the inside of the flower is this nice sort of bright UV color where the outside is a plain old white. And so that just sort of says to bees, hey, come in here to the middle of the flower. You know, gather this nectar. This one has some stripes. So they've shown that these stripes basically act like big arrows pointing the bees to the middle of the flower. There's been research where they pulled the petals off and turned them around so the arrows point out and glued them back onto the flower. And bees will land on the flower, turn around, and walk off the edge because they're following the arrows. But scent, of course, is another major attractant. And some flowers have different textures around the nectary, so bees can feel it with their feet and see that there's a major difference. So pollen foraging. So bees will always forage for nectar, all the time. They always want nectar, they always want to make honey. But bees will only forage for pollen when they are being stimulated by the presence of brood, or by a short day length. So in the winter and springtime they'll forage, and when there's lots of brood they'll forage for pollen. But it's not uncommon in, say, late summer or early fall, when brood production is really low, to see a major drop-off in pollen gathering, just because there's not much brood stimulating them. Generally, bees perform a behavior called scrabbling when they're gathering pollen, which kind of just looks like they're throwing themselves on the anthers, which is kind of what they're doing. Basically, they're just trying to dislodge as much pollen as possible onto the hairs all over their bodies. So they'll crawl around on top of the anthers. They will use their mandibles to strip the pollen off and to put it onto their legs. They'll use any number of behaviors. But the important thing to take from this is that behavior is learned, just like the nectar gathering is. So when bees encounter a new flower, they're going to be inefficient at first and get better and better at getting pollen from it as time passes. Another thing we see is that many flowers are actually evolved to force the bees in, like I mentioned before. So a nice example are these tubular-shaped flowers. where basically the entrance to the flower is so narrow that the bees are forced to crawl inside to get to the nectar. And they put the anthers, as you can sort of see right here, right at the tip. So if the bees want to get the nectar, they have to brush up against those anthers and gather some sort of pollen load, even if they're just out there gathering nectar. And this is the bee cheaters I was talking about. So as I mentioned before, if bees are out there gathering pollen or gathering nectar, right? Sometimes the easiest way to get nectar is by avoiding the anthers and finding tricky ways to get the nectar without actually touching any pollen. So there's a couple examples of this. Some bees, what they will do is they will actually chew holes in the petals right above the nectaries. So they'll chew a little hole with their mandibles and they'll insert their tongue in and pull out the nectar that way. Some bees will visit extrafloral nectaries, so that's what's going on here. There are some nectaries at the base of the flower, and they can access those without entering the flower. And there was actually some research in apples where they demonstrated that some bees, what they'll do is they'll crawl up behind the flowers and they'll stick their tongues up in between the gaps in the petals and sort of like snake them around and into the nectaries that way. Although that only works on flowers where there's a big enough petal gap that they can reach in. So bees will cheat. Okay, water and propolis forage. So this one's interesting in my mind because it's a slightly different behavior from pollen and nectar. So pollen and nectar get stored, right? So basically, bees are hoarders. Bees hoard. If there are resources available, they will go out and gather it and they will store it away. As long as they can build comb and expand, they will store for later times. But bees do not have a mechanism to store water or propolis. So if they need water or propolis, they are constantly going to have to forage for it. So generally, what happens is if you're a water forager or a propolis forager, what you do is you fly out, you collect the propolis, you collect the water, you come back, and then you serve as a living reservoir in the hive. If other bees need propolis or water, they'll come up to you and they'll ask for it. You regurgitate a little bit, or you scrape some off of your legs if you got some propolis built up there. And basically, you just hang out. And then once you're fully empty, you return out to the site and you get some more and you come back and you're a reservoir again. Now, if it's a really hot day and there's lots of water needed to keep the hive cool, there are situations where the bees fly back and they're immediately empty before they even get into the center of the hive. And in that case, these foragers may go to the brood chamber or to the unemployed workers and do a dance for water or propolis location, but generally they don't. Oftentimes the need for these resources is so low that a really minimal number of them can go out and find it. As far as water is concerned, bees like water, bees need water. You need to provide them with a water source.
Are they really clumsy around water reservoirs? Because I remember actually talking to a friend of mine whose uncle works with bees, and he always complained how bees always drown in the buckets of water that they would provide for them. So are they like clumsy around water, or
I think they kind of are. You hear a lot of stories like that, like bees drowning in buckets of water, bees drowning in swimming pools. I think part of it's going to be how suitable the water source is to the bees. So if you give them a bucket, right, that's a steep plastic surface. It's easy to fall into the water. But at the same time, a natural water source for a bee is usually going to be like a pool, right, with shallow edges, good dirt to grip onto. So the other places, oh, we're almost out of time. So I don't think they're super clumsy, but who knows? Anyway, bees seem to prefer water with a scent, but that's not always available. And as far as propolis is concerned, the bees collect this by finding a plant with resinous exudate on it. they'll collect it and put it onto their legs and their pollen baskets. So you'll see them running around with sort of these waxy, resinous-looking blobs on their legs. Boy, we're going to hammer through this real fast. Optimum foraging strategy. This basically is just touching on the idea. Let's turn that down. Optimum foraging strategy is just touching on how bees make decisions when they're foraging. And the main idea here, and this is the takeaway, is that, as I mentioned before, foragers are conservative. They're going to favor things that are closest to the hive and most profitable. And they're also going to show preference for the species of plant they already know how to forage. So generally, they learn their behavior and they stick with it. If there's lots of forage available, bees stay close. If conditions are poor and there's not good forage, foragers will be forced to fly on and to examine further resources. Generally, what we find, though, is that to avoid being lost, what foragers will do is if the flowers aren't very good, they'll basically visit a flower, and then they'll just keep flying in the same direction they entered the field. Someone was tracking foraging behavior in a crop that was almost done producing nectar. I think it was onions, and they showed that the bees actually would fly down the rows of onions and visit every plant in turn, and that way they could just turn around and fly back down the row to the hive. Okay. Yeah. Okay, robbing. So robbing can be thought of as foraging, but foraging for honey. Bees, as I mentioned, are hoarders and they are opportunistic. So if bees sense an opportunity to steal honey from other bees, they will. Generally, they will steal honey that is exposed. So if a hive is opened by a keeper and they don't put the lid on pretty quickly, other bees from other hives will come and start dropping into the box and try and take honey. Similarly, let's say you have a bunch of strong hives and you have one hive that's pretty weak, just hasn't been doing good all season. It's not uncommon for workers from that hive, the strong hives, to basically invade the weak hive and steal the honey from that. And in extreme situations, they can rob the hive to such an extent that they completely clear it of honey and the hive will collapse because they have no food. This is typically most common when nectar resources are low, so you got to watch out for honey robbing, mostly in the late summer, early fall, when there's lots of unemployed bees buzzing around. Unemployment's bad for bees. All right, so this last section I wanted to point out, I'll just give the really brief version of this, is seasonality of bees. So the basic idea is that at different times of year, you're going to be using different resources with bees. They're going to move from source to source to source. They have a section of this in the book, and I didn't particularly like the section in the book because it's really slanted towards the East Coast and the Mid-Atlantic states. Because they point out, oh, well, if you move your bees from here to here to here to here to here, you'll be fine. But here in California, we have this Mediterranean climate, right? And so we don't necessarily just have an endless number of flowering sources all year round. So it didn't really apply. But the major takeaway I got from this was functionally that in early to mid-spring, you'll have the emergence of our initial flowering crops, weeds, ornamentals, and also some of our fruiting trees like the stone fruits, almonds, things like that. Bees primarily use this to build up their brood. So they're going to be out there foraging that, building up their honey stores, not building up their honey stores, but building up their pollen, building up enough honey, and transferring almost all of that into brood production. And then for the rest of the season, you're mostly transmitting bees between what are called honey plants, or basically plants that provide very high nectar resources so that bees can utilize them and produce excess honey. And I tried my best to look around and figure out what bees were actually doing around California.